Hi, Assalamualaikum. My name is Muhammad Fahmi bin Fauzi, and I'm going to present my final year project, which titled Evaluation of Wave Prediction of Wave Pattern and the Hull Performance of MTC101 and MTC102 hull form using commercial software. Before that, my supervisor name is Encik Nasruddin bin Haji Ismail, and my co-supervisor is Dr. Arifah binti Adi. Okay, this is a table of content. Firstly is background, literature review, methodology, result and discussion, lastly, conclusion and reference. In the background, this project is going to evaluate the previous student CFD simulation result from the open source software with the commercial software. So previously, the student was studying in the open form software, which is open source software, and the commercial software that I'm using is NCCFF. Okay. The objective is to determine the free surface wave pattern and hull resistance by analysis the compute flow field using NCF. Next, to assess the hull resistance obtained from the analysis with open form and the model test result. My scope of study is cover using MTC101 and MTC102 result from open form analysis from previous student to use NCF for the CFD run. The outcomes such as hull resistance and modeling of the hull will be compared and assessed with the result. So the problem statement firstly is what is better platform of software to make an analysis of free surface wave pattern and hull resistance, either commercial software or open source software. Second is how much the difference in terms of accuracy between commercial software and open source software. In the literature review, I'm focusing in the resistance of the ship. In a short, resistance of the ship is force required to tow the ship at the speed in the smooth water. It was assumed no interface from the towing tank. It was stated by Edward Lewis in 1988. In conclusion, the total ship resistance is equal to frictional resistance, wave-making resistance, air or wind resistance, appendage resistance, viscous resistance, and roughness resistance. Okay, this is the type of hull. So for MTC101 is placed in the left-hand side, which is in planing hull, while MTC102 is semi-displacement hull in the middle. Okay. This is the detail for MTC101. As you can see, the table is show the hydrostatic particular for MTC101, and this is the detail for MTC102. The table shows the hydrostatic particular. The theory of the software in NCCFF governing equation that I'm using that is Navier-Stokes equation, which is a closure problem. This describes how the velocity, pressure, temperature, and the density of a moving fluid are related. However, for the turbulence model that I'm using is two equation model and K omega base SST model. Okay, for K omega SST model that I'm using is formula need to find, and the value will be insert into the solution part in NCCFF. So K is energy in turbulence while omega is the scale of turbulence. So the merit of K omega SST can be used for boundary layer problem, can be used low Reynolds flow application without extra damping ratio. Okay, next, I'm moving fast. Type of simulation that I'm using is steady state and rigid body solution. In a steady state, the characteristic of domain do not change with time. And the steady state condition are assumed to have been reached after a long period of time. Okay, in the rigid body solution, to determine the motion of rigid body, a solid object that moves through a fluid without deforming by fluid force and torque or any external force acting on it. Okay, next. Okay, this is the computational fluid dynamic, in short, CFD. This analysis characteristic of fluid by using computer. So we have to type in general, which is open source software and commercial software. So in my case, I'm using the method to solve my problem by finite volume, and the field usage of CFD is fluid flow problem. So this advantage of using CFD. Okay, moving on to CFD flowchart. So firstly, pre-processing is the very important part because they include the modeling part and meshing. By solver also important, which is you need to set what is the equation there and how the fluid moving on your NCs. Okay, for post-processing is the result of your run simulation. Okay, for this overall flow chart in the simulation, I will repeat it again. Firstly, we need to remodel the model using any software, but I'm using the rhinoceros to modeling the MTC101 and MTC102. After remodeling the shape, check the hydrostatic particular with the experimental. Okay, so and then after the validation is done, draw a suitable domain, meshing the model analysis, pre-setup in NCCFF, pre-solver in NC Solver Manager, and post-processing in NCs. Okay. Okay, this is NCCFF. You have a meshing part here, setup, and the solution. Lastly, the result. Okay, this is the result for MTC 101 and 102 remodeling in Rhinoceros. After that, you need to check the percentage error of your modeling. Okay, for my modeling, I have done below 10%, yeah. And for MTC 102, also below 10%. And next, I will going to draw a domain. Okay, for the domain, you need to follow the ITTC recommended sizing, where you need to put your model position. Okay, after that, in the domain, you can see you need to set the inflow of water, the outflow, the top hull, wall, bottom wall, and the free surface. You need to determine by yourself. Okay, this is the example of meshing. Okay, MTC 101. You can see in the middle the cubic, refined cubic and hull which locate, and at the straight line is the free surface area. This is my CFF pre-setup. User mode, general mode, analysis type, steady state, domain type, fluid type, ANC water, turbulent model, AST model, heat resonance, buoyancy model, buoyant flow, and homogeneous model. Okay, the boundary condition, as you can see like this. Okay, so we're going to discuss about the result for MTC 101 and NCs versus experiment. As you can see for overall, the percentage difference at a different speed. The percentage difference is very high for me because this is run is not take consideration of trim angle. Trim angle is important because the experimental have done by trim angle. So as you can see, all the percentage difference are quite far. Okay. However, I have tried to apply the meshing analysis in my result. So by using the coarse mesh in the same speed, coarse mesh give the 22.50%, while the fine mesh, you can see, it give the low percentage difference. It means that we need to make the meshing very fine mesh to get the low percentage difference. However, it takes too long time. Okay, next we move to the analysis versus open form. As you can see, the percentage error for overall average percentage error for NCs is quite bigger, but open form result is low compared to the NCs. This is the graph comparison between three experiment, NCs, and open form. The Y is resistant and this is the speed. Okay. So the discussion is trend line of NCs is similar with open form at untrimmed condition. The NCs result is quite different to the experiment result compared to the open form. NCs produce much bigger resistance compared to open form. This is because the condition of trim angle is not included into the simulation setup. So this is the result for MTC101. You can see at the different speed, the wavelength from NCs is bigger compared to the wavelength from open form. Okay, this is the preview of wave pattern MTC101 with a different speed. As you can see, there are different wave pattern is generated. Okay, so the discussion for wave pattern, the wave pattern produced by NCs is small, different compared to open form. The wavelength much bigger than open form result. When the speed is increased, the wavelength also increased. The wave height also increased as the speed is increased. Okay. Next, we move to the result MTC102 NCs versus experiment. In this result, you can see there are small percentage difference to compare by MTC101 because in MTC102, I have applied the trimming angle. So this is the trimming angle setup. I get the data from the MTC. Okay, the result NCs. Oh, sorry. Okay, the result between NCs and open form, as you can see, the percentage error at a high, the lower speed, the NCs give 12.84% difference. However, percentage error for open form is 10.05. But in the higher speed, the percentage error is 2.25 for NCs. For open form, the percentage error is 8.45. It means that the NCs will give a better result when the ship is moving faster. So the average also smaller compared to the open form. Okay, this is the result graph for the three experiment NCs and open form. So the discussion is, unlike the MPC 101, the graph shows the result of MPC 102 is approached the experimental result. The reason for this is because the trim angle have been applied for the simulation setup. The consideration of trimming angle is needed. Okay, next is the comparison of wave pattern result. There are only one comparison that I can give because the previous student only showed once. Okay, for the lower speed in 1.38 millisecond, the wavelength for MCs is smaller compared to the wavelength from open form. This is the preview of wave pattern MTC102. As you can see, the different preview of wave pattern is applied. Okay, the discussion is, the wavelength is increased relatively when the speed is increased. The result from NCs is much smaller compared to the open form. And lastly, the pattern of wave is same as the resulted in MTC101. Okay, last but not least is my Gantt chart semester 1 and Gantt chart semester 2. And in conclusion, the objective is achieved, but the modeling of ship with lower percentage difference need to be applied and compared with the hydrostatic particular comparison. Rerun of NCs on MTC101 should be done on trim hull as to compare with the experimental result. And this is my reference, and thank you very much.